Every time you open an app, train an AI model, or pull data from a cloud server, you are relying on a single, universal concept: general-purpose computing. But if you rewind past 1936, a computer was not a physical device. It was a job title given to humans performing tedious, manual calculations by hand. The scientific community faced a rigid barrier. No mathematical blueprint existed for an automated calculator because scientists simply did not know the theoretical limits of what could actually be calculated. Alan Turing, a brilliant young mathematician studying at Cambridge and Princeton, took on that exact problem. He wanted to prove whether a hypothetical machine could simulate any algorithmic computation given to it. In his 1936 paper on Computable Numbers, he outlined a solution that defined the mechanical requirements of logic itself. This is the Turing Machine, a continuous tape acting as memory, and a read-write head modifying symbols on that tape. Crucially, Turing proved this mechanism could be universal, programmed to perform the task of any other machine, just by changing instructions. This realization that one physical machine can run any program effectively invented the concept of software, providing the intellectual blueprint for every computer built since. When World War II broke out, those abstract mathematical theories were thrust into urgent reality at Bletchley Park. The immediate threat was the German Enigma cipher. The device could generate millions of randomized, highly complex mechanical settings every single day. Turing led the design of a practical solution called the Bombe. This electromechanical array systematically tested those millions of combinations to crack the code. By outthinking human encryption at scale, historians estimate this machine shortened the war by as much as 4 years and saved over 14 million lives. After the war, Turing escalated his focus. If a machine was capable of complex calculation and code breaking, he asked if it was also capable of thinking. He explored this question formally in his 1950 paper, Computing Machinery and Intelligence. This setup illustrates his imitation game, or the Turing test. An interrogator interacts with two hidden subjects, one human, one machine, and tries to tell them apart. If the machine's responses are indistinguishable from the human's, Turing argued it achieved a functional state of thought. This shifted artificial intelligence from a philosophical debate into a measurable engineering target, providing the benchmark that still drives the industry today. Turing dedicated his life to expanding the logical capacity of machines, yet he lived in a society that often failed to apply logic to its own citizens. In 1952, the British government prosecuted him for homosexuality. As an alternative to prison, he was forced to undergo a year of chemical hormonal treatments. He died 2 years later in 1954 at the age of 41. His death was officially ruled a suicide. The injustice was only recognized decades later. The British government issued a formal apology in 2009, followed by a royal pardon in 2013. Today, computing's highest honor bears his name, and his face appears on the British 50-pound note, a national symbol of his contribution to science. Turing's work gave us the architecture of the modern world, but his end serves as a warning. Scientific progress is only as durable as the dignity we afford the minds that create it.